Hello! Hello! Welcome to the very first CodeBreak online workshop. We're going to see how well this goes, so if you have any comments, feel free to let me know. I have like a little iPad down here with the live chat on it, so if you have any questions or comments, think that something is not being explained well enough, whatever else, I can see it. It's probably like a 20 to 30 second delay is my guess, round trip, before I see your comment, and then the video actually makes it back up to you, so it might be a little bit delayed, but I will do my best to answer whatever questions you have. So today's online workshop is going to be Intro to Databases. Again, tomorrow we are going to be doing a workshop on building web servers. So if you've always wondered, how does something like Facebook work? Do they just make a bunch of static HTML pages and put them in a directory? Well, the answer is no. And we'll talk about how that works tomorrow. And then on Friday, we're actually going to do a workshop on game design. So if you want to know how to make games more fun, we'll talk a little bit about that too. If you are watching this recorded, then both of those workshops are probably already up there, and you should just be able to find them on our YouTube channel. So today's topic, we are going to be talking about Intro to Databases. Intro to Databases is a pretty exciting topic. If you've never used a database before, it might sound really daunting. So the question is really, first of all, what even is a database? And then second of all, how do we use a database and those sort of things? How would you use it in your project? Before we even get into that, why are databases important? So if you think about how you store data right now, you probably store data in variables, right? That's what you use to keep your data. And maybe you have like if you're using Java, you have like an array list, or C# I think just calls it a list. Maybe you have a dictionary. That's really exciting. But the problem with all of those data structures is that one of the problems with all those data structures is that when you close your program, all of that data is lost. And that's not really a great thing if, for example, you were Facebook and your server goes down because an intern accidentally pushed a bit of code that breaks all of Facebook, which happened. It's not great if you would lose all that data. So you're probably not going to want to store it in variables. And there are a few other things that databases can be better at than variables as well. So we'll talk a little bit about that as well. I would just to answer some questions in the live chat. First of all, hi Edward. For anyone who doesn't know, Edward in the live chat is the original founder of Student R&D. Is probably more than qualified in databases. So it's great to have him here in a way. Leo asked if I'd suggest taking paper notes. Probably not. This video will be available immediately afterward, but I'm actually going to end this slide deck with just a list of things that I'd actually recommend you Google. So my goal with this workshop is actually not to give you a complete overview of everything to do with databases. It's actually just to explain enough about databases that you'll be able to make, if you need help from someone in the Student R&D Slack or you want to Google something, that you'll be able to get an intelligent question out so that you can get your question answered more quickly, because often asking the right question is often the most difficult part of figuring out what to how to find the answer to your question. So don't recommend taking paper notes. Just hang out there until the end. If you really want to, that's totally cool. But yeah. So we're talking about databases. Again, a more persistent way of storing things than variables for sure. What else is an attribute of a database? And what are some databases that you've used before? Oftentimes when I talk to people about databases, they get really afraid because they've heard that databases are a thing and they don't really know what they are. It's kind of the same as coding, right? Before many of us started coding, we thought programming was writing ones and zeros. With databases, it must be something really daunting. Well, here's a really simple version of a database. Excel is a database. If you look at, this is a list of all the names and CodeBreak projects. This is something that we sent out on the very first day of CodeBreak. Excel is kind of a simple database, right? We have a list of a bunch of stuff, names and projects that people are working on, and they're sort of organized in a way that makes it easy to find. Again, if I close Excel, it's all still there. It's saved in some particular format. So it's kind of a database. And in fact, you can actually write code that does work with Excel. And we'll talk about how databases work with code a little bit later, but you could use Excel as a database if you wanted to. There are some disadvantages, there are some advantages. There's not really a lot of advantages. There's probably one. But Excel does have some of the characteristics of a database. So other than storing data in a way that is intuitive, which we'll talk more about that, what are some characteristics of a database? Well, the way I think about it, databases store things in a way that can be read to or written from quickly. That's one major characteristic of a database. Why is that important? Most applications that need a database need to be doing it, need to be accessing data for a large number of users. Even something as relatively small as CodeDay, at least compared to Facebook, we still have a bunch of students who are attending, and we need to be able to store data for all of those students. So reading and writing data quickly, at least relatively quickly, is often a thing that you're looking for in a database. And in fact, if you're using, text files, for example, to store things, you're just reading and writing from text files, well, that's probably pretty slow. So reading and writing quickly, important factor of most databases. Searching and sorting is also a really important part of having a database. Why is that important? Well, let's say that I'm in the student R&D Slack and I want to know, what is this person working on again? Well, going back to my database of this Excel spreadsheet, I can just Control F for someone's name, find their name in the list, and then find what it is that they're actually working on. Or vice versa, if I vaguely remember, hey, someone's working on a project for home automation. Who was that again? I could also Control F, and assuming I could describe the project somewhat reasonably, could probably find the name of the person who's doing things based on there. So searching and sorting things is also an important characteristic of a database. And then finally, structured in a known way. So again, going back to this database, it's very intuitive what is where. And the fact that things are grouped together. So first name, last name, and project are all in one line. All of the first names are in the first column. All of the projects are in the third column. That's kind of a known way. A known way of doing things. So Leo in the chat actually asked, so is it the case that most databases would implement searching and sorting themselves? And yeah, kind of. There's a really easy way in most database query languages, which we'll talk about later, of asking for a sorted version or asking for things that only fit some particular criteria. So we'll look into that a little bit in a second. I want to just bring up a few quick terms because we're going to be talking about them throughout the rest of the thing. They're really important. I think they're somewhat intuitive, but it's worth going into. Tables store related data. So code days, for example, if I'm doing something for managing code day registrations, maybe code days is a table, attendees is a table, projects is a table. They're related data. They're related types of data. So for example, I probably wouldn't store attendees in the same place as code day events, because a code day event has like a start time and a stop time and an address and a maximum capacity, versus an attendee has like an email address and the amount that they paid for their ticket. So all of those things are totally unrelated types of data. So generally, when we're talking about databases, we're going to store related data together. Now, sometimes you'll store all of your data in one particular place if you're using certain types of databases. We usually call those NoSQL databases. We'll get to those at the very end. I'm not going to go into them too much. They're sort of both a more advanced topic and there's a lot of variety in how you do things there. So in this particular talk, if you know anything about databases, we're going to talk about relational databases, traditional SQL databases. And so, if you're getting frustrated because I'm saying something and it's not 100% true, well, that's true of most workshops. But in this particular case, we're going to talk about table storing related data. So we wouldn't store attendees in the code days table because attendees have different types of data. Columns group specific types of data. It's called a column because, again, if you go back to something like Excel, it's literally a column. First name is a column, last name is a column, project is a column. You wouldn't expect to find someone's last name in the what are you working on column. It wouldn't make sense. The project would not be stored in the first name column. Again, unless someone filled out this form really poorly, in which case, maybe. But in a well-made database, that would not be the case. So columns are the things that store related types of data. Rows group entries. So again, going back to this, each row in this database is a related thing. Someone's first name, on row 2, Nicholas is Nicholas's first name, Hugh Becker is his last name, and an Electron dashboard app is the project that he's working on. And you can expect those all to be in row 2. If something is in the same row as something else, it means it's related to the same object or concept or something like that. So it's kind of intuitive. It's kind of what you'd expect from Excel, but I just wanted to make sure you know the terms. Tables are storing related data. Columns are grouping specific types of data. Rows are grouping entries. What is a table, by the way, in Excel? It's kind of those, you could either make a new Excel document, or it's actually at the very bottom they have those tabs. In this one there's a tab that says Sheet 1. That's kind of a table, right? And if I wanted to store something else, then I would probably make a new sheet. Cool, so let's go into an example table. Let's go into that code days table. Here's an example of a code day table. Again, it looks kind of like Excel. This is something I made in PowerPoint. Most database tools will not directly draw a table. We'll show you how to do that in a bit. But here's a table. Here's some example data in our table. So we have a start date, an end date, a name, an address, a capacity. All of these are real code days that happened. I think these are the first 4-ish code days, except I think I couldn't find the date for one of them, so I just made it up. So those are some example data. And again, it looks kind of like Excel spreadsheet. People in the chat, by the way, are talking about user validation. We'll talk about that a little bit too. We have a section on security. So again, I called this a relational database, and this is one of the parts that make things useful. Right now, this is kind of like maybe a list of dictionaries. If you're thinking about this in Excel, or sorry, in Java terms, maybe this is like an array list, and inside the array list has a dictionary, string to string. So it's kind of like that. It kind of persists things. But one of the really cool things is that databases are relational. So if we have that table of events, right? How do we go from a student to an event, right? We have students separately. Again, we're talking about that. Attendees would be another table, and we have events. And how do we know which event a student is attending? The way that we're going to do that is we're going to just reference it. We're going to say, here's the thing. In order to do that, we need to be able to uniquely identify each code day. So we'll give it an ID. By the way, yeah, when I'm talking about a dictionary, hash map is also a similar term. So you need to be able to uniquely identify each object. Most databases can give each thing a unique ID. This is also a really good example of why almost any service that you sign up for, you'll have a user ID. Or maybe sometimes you have a username. It's important to be able to uniquely identify things for a lot of reasons, but this is one of them. I will add, for example, this auto increment thing to this table, and now I have an ID number, and each ID number is separate. So now, let's say I want to start tracking ticket sales, and I want to know who is it that registered for a particular event. Well, again, each attendee is going to have their own ID. They're going to have a name, they're going to have a last name, they're going to have an email, and they also have this new field called Code Day ID. And Code Day ID just happens to be a reference to the ID from this field. So if, for example, you can see the very first row, attendee ID 1, has a Code Day ID of 1, that means that I attended the very first Code Day. Code Day Seattle, December 2011. That sort of reference there is a thing. So if I wanted to know, hey, what's the name of the Code Day that Kevin went to, I could go ahead and look that up, right? I could say, okay, I see that Kevin, who is ID 7, attended Code Day ID number 2. And in the Code Days table, Code Day ID number 2 is, Code Day Seattle, February 2012, which I think is actually probably not the first Code Day that Kevin attended if he's watching, but I don't think he is. So, that is the other really important component of databases that we're going to talk about is relational databases. They are relational. Well, this will come up a lot when you're trying to do things because you're generally going to want to store multiple types of data and have them related to each other somehow. So I did want to get that right out of the way, that relational concept, the concept of giving everything a unique identifier, and then being able to reference, oh hey, Kevin attended, code day ID number 2. So we'll get that, again, that was a conceptual thing, we'll get that out of the way. So let's go ahead and start talking a little bit about the real, meat and bones of how do we actually get, tables to exist in the real world. So it's not like Excel. Again, you could kind of use Excel as a database, but most databases are going to use something called SQL or SQL. It's short for Structured Query Language. And like with Java or Python, you have to write it in a specific format. It is a language. You can't just say, hey, get me this thing. It's much like programming. You have to be very specific about what it is that you want, or what format you want it in, how you want to select things, those sort of things. There are multiple types of databases. We'll talk about what database program options you have at the very end, but again, I'm going a little bit more conceptual at the beginning. So most databases will use SQL, though. And there are 2 places where you can run SQL code. One is in the command line. So for MySQL, which is a really common one, again, we'll talk about that at the end, a really common database, there's just a program called MySQL. In the other situation that you can do it is you can actually run SQL in a program and have the database return back to you the result of your query. And again, we'll go into examples of what queries are. You can actually run SQL from a program and get back a result. So let's look at some examples of what SQL actually looks like, because I know I've been talking a lot about SQL and haven't actually gotten into it yet. So here's a really simple SQL query. Select star from attendees. Again, we had that table of attendees. We want to select star from that. So star means all columns. The reason that it's a star is it means all columns. We could select a specific column. We'll talk about that in a second. But in this case, we want all columns. And by default, MySQL or most databases are going to return all rows in that database. And because of the star, it will return all columns. So here's a list of all of our Code Day attendees for a really simple, small version of Code Day that probably would not be very successful because it looks like at most 3 people are going to an event, or 5 people are going to an event. So if you want to be more selective, which is a pun, we can actually replace that star with specific ones. So select ID, email from attendees. And then in that case, we're only going to select an ID and an email. Again, this is literally the code that you're writing to go ahead and select things. To go ahead and select something from the database. This is the code that you're going to run. So let's look at what that actually looks like in the real world. This is multi-screen, so let's see if I can get this over here. And I can't really see that, so let's hope that I can do this. So I'm going to go ahead and run MySQL. Again, that command that I told you existed. There's the MySQL command. I'm going to go ahead and run that. It's going to ask me for a password. My password is banana. And we're going to go ahead and run it. So MySQL can store multiple databases, right? It's a database, but it can kind of store multiple databases. Databases are groups of related tables. So it's kind of like making a new Excel spreadsheet. And then again, you have those individual sheets inside of it, but you have one Excel file. That's an example of this. So in this case, I'm going to tell it what database I want to load. I've already created one. The way you create a database in MySQL is you type create database and the name. It's kind of like making a new Excel file. Again, if I'm saving that. The way I tell it that I want to use one is I want to say use, and in this case, I called it code break test. And I can't actually see what that said. Let's see if I can get my display to mirror. Let's go ahead and try this. Here's my that? That's a little bit better. Oh, you know what? I think I called it CodeBreak demo. So use CodeBreak demo. Cool. Okay, so we've gone ahead and we have the CodeBreak demo, changed. It's kind of like file open in Excel. We've opened this database. Again, I've already created it. And now let's go ahead and get a list of our tables. And in this case, I've only created one. It's called code days. And you can actually see in Excel, and let's see if I can I make this a little bigger? Is there a way to make the font bigger? There's probably a way to make the font a little bit bigger. Terminal zoom. Zoom. And let's go ahead and do it one more time. Cool. So you can see there's actually, MySQL does actually draw it as kind of a table. This is actually a column. This is a table with one column called tables in CodeBreak demo. So let's go ahead and run that really simple query, the select star from code days. And again, just like in many programming languages, but not all programming languages, in MySQL, everything does have to end with a semicolon. So I'm going to go ahead and hit enter, and there we go. You can see our table, and it actually drew it in sort of text, which is kind of cool. Using pluses and dashes to represent the table. All of the things inside of our database. Now, how do we create that table? We'll go into that a little bit later, but right now we're going to go with the most simple thing, which is selecting. Yeah, so there's our table. Let's say we want to select only, maybe the name and the capacity from code days. Again, don't forget the semicolon, and there we go. So now we get, we've asked MySQL for, just for those particular ones. We can, some other things that we can do though is we can also select different, right now we're showing all the code days that are in this table. I've only put in 2 of them because I didn't want to type all of them. Let's say that we want to actually go in and only see the ones in 2011 or something like that. We could do that as well. I'll talk about that in a little bit. But let's go back to this really quickly. Display settings. Let's see if we can go back into from current slide. Is this gonna work? There we go. Okay. Is it working? It's kind of working. Seems like whenever I open up PowerPoint, it insists on opening presenter view, which is a little bit annoying. Is this gonna work? I think duplicate slideshow. Cool. Okay. The way that we select particular rows, if we want to see only one particular row, is to use the where clause. So this is kind of like writing a really weird program. It is a programming language. There's a specific format for it. But if we add on to the end of it where, we can actually select specific rows in that thing. So again, in the attendees example, I can select from attendees where first name is equal to Tyler. So that kind of makes sense, I think. If I have this table of all attendees and I select only ones where the first name is equal to Tyler, it's going to, it's going to find all the rows where the first name is equal to Tyler. Kind of makes sense. You can't really do this super easily in Excel. You actually can. There is a way to do it, but it's not super made for it. MySQL and most real database programs are made for this. And again, it's easy to query in code, which is also the nice thing about it. So again, going back to our real life example, let's go ahead and select star from code days where, let's say maybe where the ID is equal to 2, which is a really simple where clause. And I'm only going to get one code day back. And I can kind of combine that with the other thing that we were talking about. So maybe I can select the, let's only select the start date. And now I know for code day number 2 that it starts on February 11th, 2012. Which actually is kind of useful. How many of you knew that the second code day ever was on February 11th, 2012? I actually did not remember that until I went and looked up the Facebook event. So, we can start to get more useful information out of databases. Now, again, this is a really contrived example. The actual CodeDay database is dramatically more complicated. And maybe if we have some time at the end, I can actually go through what are some real fields in our actual database. Have to avoid any personal identifying information, but we can go into some basics of that. So yeah, that's it's kind of a simple where clause. We've talked about selecting. We've talked about refining our selections. What about when we actually want to join things together? So what about if we want to say, hey, what was the name of all of the code days that Tyler attended? We were talking about how databases are relational. That part of databases is called a join. And in the way that you do this in SQL is to do this part right here that says inner join code days on attendees.codeDayID equals codedays.codeDayID. Again, if you go back to this, what we're saying is wherever this codeday ID matches this ID in the table's codeday, we want to combine those two rows. So basically what the database is going to do is it's going to, for every single row in attendees, say, oh, hey, attendees is the, this field right here. They have this codeday ID field, and Kevin has attended codeday number 2. Let's go to codedays table and find codeday number 2. And then it'll actually take all of these fields right here, and it will put them directly to the right of all of these fields. And it'll treat it as one really big table that's got all of these. And you can do multiple joins. And man, that seems like it would be slow if you have a really big database, right? It's actually not very slow. It is slower, but it's remarkably fast. And that's one of the really powerful things about SQL and most SQL databases. One of the remarkable things about that is that it would actually do these joins really quickly. So, that's what that whole thing sort of looks like. Insert, update, create table, etc. What if you want to create a new table? What if you want to update a table? What if you want to insert into a table? My answer for that is basically Google it. I could tell you the answers to all of these right here, but there are much better resources online for learning MySQL. So rather than going in depth into all of these, I will just leave you to Google that. And I'll actually, at the end of it, we can go into that a little bit. But let's actually go ahead and even open Firefox and give it a second to open. And it's going to do some things. And there we go. Okay, so MySQL create table. And this is my Vim key binding, so don't worry about the confusion about that. Okay, my recommendation, again, we'll talk about this at the end. My recommendation is going to be to use MySQL, or if you're on Ubuntu, you have to use something, or I think Arch as well. Not 100% sure on which ones are which. There's a thing called MariaDB, which is actually just MySQL. We'll talk about that. I'd recommend MySQL. The way that you would Google this is MySQL create table, for example. The one thing I will recommend with MySQL in particular is avoid the actual mysql.com results because they're really technical and difficult to read. So if you read this, it's like, wow, what is going on here? And it's not very useful. So I would actually avoid anything that's dev.mysql.com. I would always recommend avoiding W3 schools because they're usually not very correct. So let's just scroll down and, okay, here's something that's not them. This looks pretty good. So here is an example of how we create a table in MySQL. Create table, you can, if you want to, you can do if not exists. Column list, engine equals, table type. Don't worry about all of that. You can search for all of that. But here's an example. Right? Here is an example. This is why I didn't want to go into how create tables work, because if you actually look at it, there's a lot of different field types. Not null, auto increment. We talked about auto increment, so at least you know that. It's an integer. It is a varchar, all of those sort of things. I would recommend that you Google all of this. It's going to be a lot more in depth than what we can talk about here. But what I will say is that when you're creating a table, what you need to do is you need to tell it what each column type is. So is it text? Is it, you know, a number? Is it a date? All of those sort of things are types in MySQL, just like you have types in most programming languages. You need to tell it what type each column is. You're also going to need to tell it whether it's okay for it to be null, or whether it can be, you know, whether you can not have a value there or not. All of those sort of things are part of it. If you want to avoid doing all of this, you can also search for MySQL create table wizard, or something like that. There probably will be something online. Let's see. MySQL create statement online. Here we go. Online MySQL create table query generator. This is, you know, if you're new to this, this is probably something that'll help you as well. So let's go ahead and create a users table as an example. So how many fields? Probably 2. 3? 3, okay. Users, we're going to call it users. Our first field is going to be named username. Our second field is going to be named password. What type is username? Well, it's a string. In MySQL, strings are called varchars, which is a variable length sequence of characters. Most people would call that a string, but MySQL is going to call it a varchar. And in parentheses, you also need to put in the length of the maximum string that can fit into it, because that's the way that MySQL works. Strings in MySQL, if you're going to use varchar, need to be at most 255 characters. You can't make them any longer. If you want to have a longer string, what you need to use is text. What is the difference between the two? Well, again, you can kind of Google that. I'm not going to go too in-depth. Text is a little bit less efficient. Varchar is, if you have short strings, go with varchar. So what's the maximum length username we're going to support here? It's 255, because it's in parentheses. 255. Is it null? Is it not null? Let's say it's not null, because we don't want our username to ever be null. Password, same deal. Varchar 255, not null. Engine, don't worry about this. Just trust me, you're going to type InnoDB, because that's what people do. So here's what our select statement actually looks like. Or a create table statement. And in fact, if we go ahead and we copy this, okay, I can't right click, and we go ahead and switch over to MySQL and we paste it, and oh look, we have our users table. So, you know, we're going to go ahead and show tables, and we get code days and we get users, and we can select star from users, and oh hey, we got nothing in users. No surprise there, we haven't put anything in it. And again, Googling things, great idea. If you want to insert something into users, it's going to be insert into users. In parentheses, you're going to type username, password, because those are the two things we're going to do. And then we're going to type values, Tyler Menezes, and then my password will be Hunter22. And again, don't forget the semicolon. And again, you'll see username is the first thing, password is the second thing. That's why we put those there. We're saying which ones we're going to fill out and in what order. And if I wanted to create multiple users, I could do that too. Again, you can Google this. So we're going to go ahead and, you know, we inserted those. And now if we go ahead and select star from users, we'll see, oh, hey, there's our username. And let's go ahead and say we wanted to write a really simple login routine. Select star from users, where username equals Tyler Menezes, and password equals, let's say I got my password wrong and I thought it was banana. Hey, we got no users there. That's useful to know. We didn't find any user that matched that. Or, let's say that I got my password right. Oh, hey, we got one user. There's my username, right? And so yeah, I mean, that's kind of what an insert would look like as well. Also something that is useful to know. Again, all of this you can kind of Google. By the way, if you're actually doing a users table, I recommend not storing the password in plain text. Look up something called hashed salted passwords. I think bcrypt is also something you could look up. It's a really common way of doing it, but I would recommend searching up intro to hashed passwords to understand why that's important. But that's a separate talk. So let's go back to our table. Again, all of these things, I know I went over that really quickly. The reason for that is I don't want you to take notes based on this presentation. I'd love for you to just Google how to do these sort of things. It is going to be a lot easier. Okay, so how does all this help you? When you actually get into this, how is this actually going to help you store things in your app? Well, in theory, here's how it would work. Your app generates some SQL. Your app sends the SQL, and then you get the results back. It's kind of what it looks like. And then, theoretically, you go do something else, and then you make a bunch of money, it's basically Twitter's business model, right? Nothing particularly complicated going on at Twitter, but that's basically their business model right there. That is exactly how you would build a simple version of Twitter. And in fact, if you want to learn databases, I cannot think of much of an easier app to build than Twitter, because it's actually basically just a few tables. In fact, you can put each tweet, again, remember I talked about how varchar had that 255 character limit at most. You don't even need to use all 255 characters. That's great. So, that's basically the really simple version of how you would use SQL in your application. You actually go ahead and generate the SQL, you send the SQL, and you get the results back. How do you get the results back? Well, again, that's going to depend on your programming language. How would you find out how to do that in your programming language? Well, let's go ahead and Google that. Let's say I'm going to use PHP, MySQL get results. So I just search for PHP MySQL get results, and oh hey, look at this. There's this thing right here. And here's an example of how to do it. Or, maybe there's something else here. So here's another example. Does this look confusing? It's a little bit confusing, so I'm just going to skip this. This is exactly how I Google. This looks a little bit confusing. I'll come back to it if I need to. Let's go to this one. Stack Overflow is usually good. Oh, hey, this actually looks really useful, right? MySQL fetch row, and then row 0, row 1. So this is the simple version of how you do it. If you want to do it in Python, Python MySQL get data, and this is difficult to read, but it looks like, oh hey, this is probably not too difficult. It's pretty well commented. This is basically how I Google things. And this is the way that I'd recommend doing things, because honestly, I don't remember how to do a lot of these things. I don't know how to do a lot of these things all the time. So that'd be the simple way of doing data. Now, I've told you all of this. I've told you all about SQL. I've told you how it works so that you understand what's going on. But from that, let's go into how are you actually going to want to do this in the real world? Because this kind of sucks. Generating SQL is going to be really annoying. You don't want to write out all the SQL by hand. Most of the times, you're just going to do a simple select statement where something is the case. Maybe you do a join. So most programming languages have something called an ORM, which is short for Object Relational Mapper. You can also search for something called active record, which is a Ruby on Rails thing, but a lot of programming languages have sort of adopted. As far as I can tell, it was a Ruby on Rails thing originally. But ORMs are a way where instead of writing out SQL, you can just do, select statements or update statements or anything else directly in your code. And it will just, it'll be similar to whatever you would normally expect. It basically just works like an object. So you can see in this case, this is some pseudo programming language that I made up. I create a new variable called me, and me is equal to the object of where, from the users table where the username is Tyler Menezes, get the first result. And in most ORMs, that would give you back a object. And you already know how to work with objects, because objects, in this programming language, maybe we do .firstname. And if I wanted to change my first name, I would do me.firstname is equal to Tyler is the best, and then I would save it. Way, 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 way easier than writing SQL directly. ORMs are awesome. And pretty much every programming language has an ORM. So how would you find an ORM? Again, let's just search for Python ORM. And oh hey, there is a list of ORMs for Python, which is awesome, right? It looks like the second result, SQL Alchemy. Maybe this is a little bit overcomplicated. Oh hey, here's a GitHub repository for an ORM, and it's got this weird looking logo, so it's probably pretty trendy. Oh hey, here's what it looks like. I just make some classes. Again, if you don't know what classes are, I'd recommend going and learning those as well, but I make some classes, and hey, I say, here's what the classes look like, and db.connect, db.create tables, it'll handle creating the tables for you, user.create, username is equal to Charlie. This looks super simple, right? And it totally is. So again, the point of this workshop is not necessarily to tell you everything there is to know about SQL. The point of this workshop is to give you the tools to Google things and to ask questions in a way that'll be helpful on Slack or Stack Overflow or wherever it is that you like to ask questions. ORMs for your programming language are one of the most helpful things because they let you work with everything in a way that is similar to the way that you would work with classes, instead of having to do all the SQL stuff. And I know there's some questions in the chat. I will get to those at the end here, because we're getting to the end. Security is another thing, another reason why you don't want to generate SQL yourself. What happened if we had this query right here? Select star from users where username is equal to, and then some variable called username. Well, what happens if we set username to quote, semicolon, drop table users, semicolon, dash dash? Here's what our query looks like now. Select star from users where username is equal to, quote unquote, semicolon, drop table users. And then the dash dash basically means start a comment, so it's going to comment everything else out. I'm going to copy this right here, and I'm going to go ahead and paste this query, because again, this query is actually just a simple select query that we put in our app. I'm going to go ahead and paste it into here. Oh, and the quotes are fancy quotes, so let's replace that. What did we call it? We did call it users, right? Yeah, okay. We did call it users. Cool. Show tables. And hey, our users table is gone. It's not great. There's actually an XKCD about this. If you're into XKCD, drop tables. And the joke of this is that the parent in this has named her son Robert, single quote, end parentheses, semicolon, drop table student, semicolon, dash dash. And of course, if the SQL is, just used in that really simple way where you just have a variable and you put it inside, oh hey, it's gonna drop your students table, Bobby tables. So, I don't know what this means. Oh, okay, I kind of know what this means. Yeah, so that's why we don't want to use these really simple ones. I'm going to go back to the slideshow. So again, that's another reason to use an ORM, an object relational mapper, because an ORM will deal with that for you. You won't have to worry about those SQL things. And let's go back to Mirror, because PowerPoint is generally probably right, but in this case not. Cool. What are some databases that you're going to want to use? There's two really common ones. SQLite, it stores it in a file, kind of like an Excel workbook. It's not very fast. It's relatively fast, but it's not that fast. And it's not great for multiple users. The reason you might want to use SQLite is if you want to store data for one person on one app, and not have multiple users needing to use the same data. So if I'm going to be logging in, I'm probably not going to want to use SQLite because logging in implies that I probably have a bunch of users. But if I'm building an Android app and I just want to store high scores, SQLite might be a good option because I'm not going to synchronize high scores between devices. Or maybe I will. I don't know. So SQLite is really great if you have one person on one device storing data, and it does need to be persisted across application restarts, and it does need to be maybe more complicated data, but it doesn't need to be multiple users across multiple devices. SQLite might be a good option. And SQLite is built into Android. I don't know if it's built into iOS, but there's probably a library for it, so that's great for that. MySQL, probably what you want to use in most cases. MySQL is a server, so for MySQL you need to be running MySQL in the background all the time. It's a program, Again, I ran the MySQL command on the command line. There's a separate command called MySQLd, and it needs to be running in the background, and it needs to be constantly running in order to query things. You can't easily, just directly edit the database like you could with SQLite, but it has the advantage that, because it is a program that's running, multiple people can query it at the same time. It will store data across things. If multiple people try to insert data at the same time, it'll be okay with that. All of those sort of things MySQL can deal with. You can have multiple servers if you need more performance. So for most web applications, for most applications where you're going to have multiple people storing data together, MySQL is your go-to. Two less common ones, MariaDB is MySQL for people who didn't like Oracle. Oracle bought MySQL. Oracle bought the company that made MySQL. So people rebranded MySQL as MariaDB. I don't know why Maria. It's literally just MySQL. It still says MySQL in most places. But if you try to install MySQL on Ubuntu, it will say that MySQL doesn't exist. Or let's say something like no release candidate. In that case, you need to install MariaDB, but all the programs will still be called MySQL. So there's a thing. There's a separate one that's called Postgres. It's like MySQL, but faster and with more features, and is dramatically more confusing. If you are more advanced, go ahead and start with Postgres. Postgres, I'm honestly not sure. I've heard both. Similar to MySQL, the SQL is going to look pretty similar. It's going to be slightly different, but it's technically better. Most people I know don't use it because it is more complicated and it's not as well adopted. So Postgres is an option. Again, most of the time you're going to want to use MySQL or MariaDB because, again, they're the same thing. Again, there's a thing called NoSQL. NoSQL uses SQL. It was poorly named, I think, by internet hipsters in sometime around 2010, as far as I can tell. NoSQL has actually existed longer than SQL, even though they both use SQL. NoSQL is basically anything that stores data non-relationally. So if it doesn't have that ability to have multiple tables and join them together in different ways, it's NoSQL. NoSQL could literally be a dictionary or a hash map. Could literally be an array list. There are some programs like Memcached, for example, which is basically just a hash map that's shared between programs. If Memcached, which is a server, if it shuts down, it loses all of the data that's stored in it. It's meant as a caching server. Redis is another one that's kind of similar. Those are literally just storing things in memory. They're kind of like a hash map, but they're called NoSQL because hipsters. So there are also more complicated versions of NoSQL. You can have something that's called a document store, which means you can kind of store like objects and sub-objects together. So maybe I have a users and each user stores its own code day. There's a bunch of different variations on NoSQL, which is why I'm not going to go into them here. If everything else in this presentation was really introductory to you, totally recommend looking up my NoSQL. They're really cool. MongoDB is a really good document store type one. I think it's called a document store. So maybe that's a good place to start. It's pretty well documented. And you can look up MongoDB. There's a few others. Apache Cassandra is one that I used. It was really awful at the time. It's probably better now. But for most beginners, I'd recommend starting with MySQL because it's really well documented. It does a lot of things. There's a good reason why a lot of people still do use it. Some people do use these NoSQL things. And for a while, it was really trendy to put everything in NoSQL. But when you actually look into it, most companies still do run a MySQL database or a Postgres database somewhere in there. So avoid this if possible if you're a beginner. Okay, so that's kind of the end of my talk. Basically, what I would recommend you Google is MySQL Getting Started and ORM and the language of your choice. If you're using Windows and you're developing on Windows, I would also add search for like Windows LAMP, Linux, Apache, MySQL, PHP, or you can also just search for Windows MySQL. You need to figure out how to install it, basically. That's the only complicated part with MySQL is because it is a program, you need to figure out how to install it. If you want to edit databases by hand, because again, we were talking about how for all of this stuff you needed to go into the command line and write all the SQL. There are programs that can do that as well. Search for MySQL GUI or SQLite GUI, SQLite Editor GUI, GUI, graphical user interface. Those things will give you editors that can connect to MySQL, and you edit things in a visual way, and it will generate the SQL for you. So that's also something that would be really cool if you're a beginner. Go ahead and search for GUI, and maybe you can even practice your things in there. I'll go ahead and do that right now. MySQL GUI Windows. Let's see what we got here. We got, oops, don't want magnifier. We got MySQL Workbench. We got Heidi SQL. That sounds kind of like MariaDB, but it's not. Oh, hey, look at this. This is kind of what it looks like, except apparently this is in Swedish or something. So, you got front ends that you can use. There's a Quora post. What's the best MySQL client for Mac OS X or Windows? Here's a list of them. So that's what I'd recommend Googling. And again, I would actually recommend that you don't use SQL if you can avoid it. It's got a lot of problems with generating it directly. I would recommend that you use an ORM. I would strongly recommend that you use an ORM. It'll make your life so much easier, and you can still learn a lot about databases while using it. So again, ORM, your language of choice, you'll probably get an ORM package, and that'll be kind of useful. So I'm going to go ahead and pull up some questions. NoSQL does not use SQL. That's actually not really true. Using JSON is actually kind of a type of SQL because it is a structured query language. So yeah, Redis, most people do also consider a NoSQL database. From what I've heard a lot of people call Redis a NoSQL database. So again, it's one of those things where NoSQL is a term that people apply to a lot of things. If you look up NoSQL online, you'll hear lots of people calling lots of things NoSQL databases. You can argue about what is and what isn't, but I know a lot of people who say that they're using NoSQL and they're using Redis. Again, it's way more complicated, so don't worry about that. So, okay, let's say that I have an app which needs to connect to another app but only allows username, password, login. How do I protect the passwords that I'm using to scrape while making sure that the plain text is available so I can log in? That is something that's not really databases, that's more of an encryption question. I would talk to some people on the Student R&D Slack and probably get a little bit more information. There. Oh, I can't scroll back any further in the chat. There we go. Okay. How would I store credentials in plain text if I wanted to, aka a password manager? I think that's similar to what he was talking about there. Yeah, I mean that's kind of the basics. If you got more questions, go ahead and send them in. I'm going to go ahead and I want to show you some more examples since we have a little bit of time. So let's go ahead and look at how, for example, when you register for a code day, this is the actual code that's going to get run. So create registration record is a function. Let's go ahead and zoom in a little bit more even. Zoom. There's probably a hotkey for this, but it's not Control+. So here's an example of code day registration. So I say, okay, we're going to create a new object. This is how you create a new object in PHP. $ means a variable. So I'm creating a new variable, assigning it to a new registration object. And I'm setting the event ID, I'm setting the first name, I'm setting the last name, I'm setting the email, I'm setting the type of ticket, which would be something like student or VIP or judge. And then I save it. And that's the advantage of an ORM, is because I didn't have to write any SQL. It already generated all of that for me. Super useful. Pretty cool. And then it does some other stuff. So that's kind of the advantage of using an ORM. Let's go ahead and look at what one code day database might actually look like. So I will go ahead and connect to one of our servers. I need to run this program because of the way that my private keys are held. And then I think it's this one. All of our servers use the GitHub name generator. MySQL show databases. Nope, it was not this one. Let's try a different server. Is it this one? Let's try this one. Sorry about this. Don't remember the names of any of the servers because they're all using GitHub name generator. Show databases. Cool, this is the one. And again, let's go ahead and zoom in a little bit. Zoom in, let's go one more time. Cool. Okay, so again, the way I load a database, use clear show tables. So here's all of our tables. Clear is our code day management application. If you look at it online, if you have access to it, it's kind of like Eventbrite if you've ever used Eventbrite. It just gives you information like how long until code day, what the state of different cities are, all of this sort of stuff. So because, obviously we have code day, we had the holidays, don't have any registrations yet, so there's nothing super cool going on there. Here's all the tables that are behind code day. So, and clear is kind of a mess, so it's got a little bit more than maybe it should. We have a table for email templates. We have a table for the waitlist, which does not actually work yet because it hasn't been programmed yet. We have a table for gift cards. We have a table for people who've signed up to be notified. We have a table for saved queries because we can run queries on there. Let's go ahead and look at some of our let's look at some of our email templates. If instead of using a semicolon you use /g, it will display it in a different way, which you'll see in just a second. And let's only see the first 2 email templates. Select star from. Here's an email template. The name of the email template is registration open. No one else is going to be able to access clear because you don't have access because you are not a code day person. But all of the code day organizers have access to clear. So that's why you're getting an error if you try to access it. So here's an example of an email template, right? So I can store email templates, and here are all my columns. This is what I was saying, it's displayed in a different way. So its ID number is 2, its name is help promoting, it sends to all attendees, it's from the event manager, the subject is help promoting code day, region name, and here's the entire text of it, and it's not a marketing email, which means it's not kind of spammy. So again, let's see some other tables here. Let's see our batches. Batches is basically like a season, the code day season, all the events that happen on the same day. You can see this is why I did /g because it's hard to read. And let's go ahead and again, we'll limit it to 2. So here are 2 batches. Here's the ID number, here's the name, fall 2017. Here is the starts at, created at, updated at. Kind of cool. What if we wanted to see all of the events that are happening in a specific batch? Well, we could do a join. So select, let's just do select here. Another way, if you want to see what columns a table has, you can use describe. So describe batches events. Here's all of the things that are, here's all the columns inside of the batches events table. So each event. So let's say we want to know the venue name of everything. So select venue name, and then what's the other one? We want to know what region it's in. Region ID. From batches events join batches on batches dot ID is equal to batches events dot batch ID. I think that's what it's called, right? Batch ID. Yep. Limit 10. Hey, that's kind of cool. Except we didn't actually see the batches anywhere. So let's also select something from the batches table. So the batches table has a name. Cool. So there we did. We just did a join. We see all of these are, on the winter 2015 batch, and here's the name of the venues, and here's what region they were in. It's kind of cool. We could even join the regions table if we wanted to. So we'd add another join regions on regions.id equals region on, batches events.region ID. Limit 5. And that worked, except we didn't select anything again, so let's select regions.abbreviation. Cool. So there's some examples of some queries that might run on a more complicated database. And again, this is our actual production database. So that's actual information that's being stored there, which is why I can't select any students, but you would also be able to see some students. I guess I could, let's do this. Let's select first name, last name from batches, events, registrations, where email is equal to tylermenezes@srnd.org. Cool. And there are some random people that have registered because I registered other people. But anyway, cool. So yeah, so there's some examples of some actual real production database stuff. I think that's pretty much it. Any other questions, last minute questions in the chat? Otherwise, again, you're always free to ask us for help on the Slack. There's the help desk channel, and we will do our best to help you. Really, Googling is sort of the way to go when it comes to this sort of stuff. And then the other thing to keep in mind, tomorrow we're going to do a workshop on web servers. If you've ever thought, hey, it'd be cool to make a website and not have a bunch of static HTML, or hey, I have a bunch of PHP files, because that's the way people make websites. If you've ever thought, hey, I want to make a website, but I have all these PHP files and this seems like kind of a mess. And how would I make a website in, let's say, Java or C# or Python? This will be the workshop for you. You'll also learn a little bit more about how the internet works, which is pretty cool. So it'll be a lot of fun. And then Friday, we're going to do a thing on game design. Again, same time every day. Game design is going to be a little bit more focused on things like, hey, how do we make our games fun? How do we make sure that we're not wasting our time? Those sort of things. So all that coming up later on in the week. If you're watching this recorded, of course, you're always free to check out the other videos as they come up. And I think other than that, that is pretty much it for us. So I will see you again tomorrow.